In this video, I'll provide an overview of encapsulation. Encapsulation hides object fields. That is, it makes them private, and it uses access control to hide the fields. Safe access using public methods is provided by the getter and setter methods. In setter methods, we use code to ensure that values are valid. Encapsulation mandates programming to the interface. A method can change the data type to match the field, and a class can be changed as long as the interface remains the same. It's one of the four main cornerstones of object-oriented design, and encapsulation encourages good OO design. So, if we make attributes private, how can another object access them? One object can access the private attributes of a second object if the second object provides public methods for each of the operations that are to be performed on the value of an attribute. For example, it's recommended that all fields of a class should be private, as done here in lines 2 through 5, and the fields that need to be accessed should have public methods for setting and getting their values, as illustrated here in lines 7 and 10. This ensures that at some future time, the actual field type itself could be changed if we needed to, or the getter or setter methods could be modified to control how the value would be changed, such as the value of the color code. Although the code for the shirt class is syntactically correct, the setColorCode method doesn't contain any logic to ensure that the correct values are set. On line 6, setColorCode is used to create a valid color code, R for red. But on line 10, an invalid value, Z, is used on the shirt object. But because shirt test accesses a private field on shirt using a setter method, shirt can now be recoded without modifying any of the classes that depend on it. Starting with line 6, the shirt test class is setting and getting a valid color code. Starting with line 10, the shirt test class is setting an invalid color code and confirming that invalid setting. This is another version of the shirt class. However, in this class, before setting the value, the setter method uses if statements to ensure that the value is valid. If it's not valid, the color code field remains unchanged and an error message will be printed. And it's worth noting that void type methods like this one can have return statements. They just can't return any values. Keeping the previous slides in mind, before the call to set color code, the default color value of U, which is unset, is displayed, as you can see in the first line of output. If you call set color code with an invalid code, the color code isn't modified and the default value U is still the value. Additionally, we'll receive an error message telling us to use the valid color codes, which are R, G, and B.